The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Thank you for joining us today for the in-memory session that we're about to present. My name is Jim Donahoe. I am one of the co-organizers of the in-memory group. Before we get into the session, just some past community news real quick before we turn it over to Sunil. 24 Hours of PASS is coming up, May 3rd through the 4th. Expert training delivered to comfort your home or office. Please check it out. You can register here on the links. It's always great stuff they offer there. Business Analytics Day will be June 21st, 2017 in Atlanta. All day analytics, check it out. Data Amp was today. For those of you who missed the big announcement, SQL Server 2017 is now in community preview. It looks really awesome. Check that stuff out too. PASS has tons of virtual groups for you folks. Please check them out. There's a virtual group for just about every facet of SQL Server. I'm talking healthcare, performance, virtual, cloud, anything you need to know about SQL Server, there's a virtual group. If there's not one, start one. PASS will love you for it. Some upcoming SQL Saturdays we got Silicon Valley, Edmonton are this weekend. Rochester and Calgary are the following weekend. That's in the U.S. and Canada. International, we have Israel on the 27th. Costa Rica on the 29th. If you're in any of those areas and you want to get a good day of training, please go see them. As always, please connect with PASS for a free membership. Go to pass.org. They did remove the volunteer slide. PASS is always seeking volunteers to help out run these events for them. If you're interested in volunteering, you can email us at imvc@sqlpass.org, or you can go to the pass.org website and look for volunteering opportunities there. With that being said, Sunil, are you ready?
I'm ready, Jim.
Okay, I'm going to change it over to you now. And here we go.
All right. So, Jim, let me know when you can see my screen.
I see your screen.
And Jim, how do I move the dashboard, the file option, everything away from my screen?
Yeah, just if you move the gray bar over to the right. I don't know how to undock it, unfortunately.
Gray bar.
Yeah, for the go-to meeting. Yeah, you can just minimize it down as well if you wanted to. I don't know how to.
I don't know how to minimize. Just a second. I can close it because that will kill the conference, right?
Right. We actually don't even see it on the screen.
I think I see it because it will just impact me in just a second. Okay. All right. So thank you everyone for joining. Sunil Agarwal, I'm a program manager with SQL Server team, and one of my key responsibilities for 2016 seems like old news now, right? 2017 is out. Was Columnstore index, and we actually did a significant improvements in Columnstore, both for data warehouse using clustered Columnstore index, and also we introduced a updatable non-clustered Columnstore index. The non-clustered Columnstore index was available since 2012, but was read-only, and with 16 it is updatable. So what I wanted to share with you in this presentation are some of the customer success stories with Columnstore. And the way I chose these customer success stories they were not, in some cases they were obvious choice for Columnstore, which makes sense because Columnstore was designed for analytics. But in some cases, they were not the obvious choice. We, in fact, struggled if Columnstore will be helpful here or not. And we found in some cases, it is actually helpful. So I think the key message that I want to drive in this presentation is think outside the box. I mean, just don't think, hey, if I have analytics, I use Columnstore. If I have something else, I use something else. Columnstore is actually much more versatile than you would think otherwise, all right? So that's what I want to share. So benefit of Columnstore index, and also want to share a one slider on what are the changes, the improvements we have made for 2016 on Columnstore. And the customer stories that I chose, one is health insurance company called Daman. They are in United Emirates. Other one is First American Title. This is a title company in Los Angeles. And there is a FIS. It's a financial institution. It is a big business. I think they're headquartered in New York City. And there is also M-Files, a company in Europe. Jim, are you guys able to hear me? I'm getting some signs saying network issue now.
No, I can hear you just fine.
All right, good. So this is something that I've shown. I just want to take a couple of minutes to showcase why Columnstore has been so interesting to our customers. Okay, I just want to show you a demo. You might have seen a version of it, but it doesn't hurt to look at it again. So what I'm going to show you is a typical analytics query, and I'm just gonna allow me to make it 150%. So it's just not gonna, yeah. So I'm running an analytics query, and notice I have a, let me do this. I have a fact table, right? You see a fact table, and then it is joining with 3 dimension tables here, right? Okay, these are the tables, and it is doing some aggregates here, like it is doing an aggregate, it is doing a group by, and so on. So this is, one would think, is a typical analytics kind of query, and I'm going to run this query on a schema that does not use Columnstore. Okay, so the fact table is row store based, dimension tables are row store based, and what you will see is that this query will take around 30 seconds to finish. Now, excuse me. So the 30 seconds, I'm not saying it is good or bad, but the point is the query performance will depend on the size of the data, right? And as you know, today, in today's environment, the data is increasing exponentially. So if a query was running fine yesterday, maybe today, because you have a lot more data, right? I mean, people are moving from gigabytes to terabytes, that size of data. So the query may not run as fast tomorrow when the data becomes huge, right? So it's a concern. How do I provide a responsive query to my users? So what you saw here is it taking around 46 seconds. At the right bottom, you see it took 47 seconds. So what we do, we say, let's see if Columnstore can help. So what we are doing here is we are going to drop the row store index. If there was a cluster index on the fact table, which was clustered, we will drop that and replace that index by a column store index. And it is just an index. What it does is it stores the data instead of rows, it is storing it as columns, okay? And that's all we do, okay? Now, if I run the same query I'm running here, yeah? And you will see that this query, just because we moved the fact table to column store, it ran in 4 seconds. So from 46 seconds, it went to 4 seconds. So it's almost 10x improvement, right? And if you look at the table that I just converted to column store was this, right? So that's the power of column store, that it can deliver, excuse me, it can deliver the query performance in a pretty, dramatic way, improved in a very dramatic way. And this is like a 10x on my laptop, but in production environments with many customers, we have seen the query performance speed up to 100 times, right? It's huge. Now, this is a huge benefit because if your data is growing exponentially, here is column store that can, take care of those kind of challenges. And not only your query runs faster, you can even try to see how much compression savings you got, right? So if I do this query, SPC space use, the first is for the row store and the next one is for the column store. And you will see that I got a compression here. It is 2.5. I mean, if I look at it here, this is 2.5 gigabyte and this is around 700 megabyte. So here I'm able to get approximately 3x compression. And in more common production scenarios, we have seen around 10x compression, because this is a sort of a test database. The data is not as repetitive as it would be in a common production environment, so you don't see as much compression here. So that's the key benefit of Columnstore. So what I wanted to show you was how our customers have used this technology, the Columnstore technology, in their workloads to deliver pretty amazing performance. Okay, so that's where we are. And let's see what happened here. Uh, okay. No, I wanted to show the full presentation. Uh, okay, guys, I think I'm like a little bit off here. I know what happened. Okay. Are you able to see it now? The full screen?
Yeah, that's better.
Okay, good. So at a very high level, the changes we made for 2016 was in multiple facets. One is performance. With 2016 Columnstore, it is performing much better than the Columnstore functionality performance available in 2014. And the key ingredients for that were string predicate push down, aggregate push down. We added new batch mode operators. And also we did SIMD, which is single instruction, multiple data instructions, which can speed up the processing much faster. All those things come to you with no changes to the application. So we got that. In terms of functionality, we allow now to create a non-cluster index on a cluster column store index. Previously in 2014, you could not create a non-cluster index on top of a cluster column store index. Okay. Notice I'm not saying non-clustered column store index. I'm saying non-clustered index, which is a traditional B-tree index. With 2016 again, we support row-level locking, and we also support RCSI and snapshot isolation. Now, why it is so important? Because if some of you who have been using Always On or familiar with Always On, you can offload your reporting workload to the secondary replica, right? In the secondary replica, we run those queries under snapshot isolation by default. You don't control that. All queries are run under snapshot isolation. Now, because column store index in 2016 supports snapshot isolation, now you can offload column store queries on the secondary replica. This is actually pretty huge. And then we also introduced a updatable non-cluster column store index, which is here. Now, what it does is it allows us to do a hybrid scenarios where you can run your transactional workload and analytics workload on the same tables at the same time. Okay, and this was not possible before Columnstore came along. So this is another pretty exciting aspect of Columnstore. So in the customer scenarios here, I'm going to touch upon all of those, all right? And as before, if you have questions, I think just let me know. I'll be happy to answer those questions. So the first example I wanted to take was a traditional data warehouse, which is like a no-brainer, because first thing we say to people who have data warehouse, try Columnstore, okay? So here is a company called Daman. It's a health insurance company, and they have a traditional data warehouse. They have 100 target tables and 200 source tables. What it means is, when they are moving data from their transactional systems, they move into staging tables, do some transformations, and ultimately they move those rows into target tables. And those target tables are the source for the analytics queries, okay? So as you can imagine, there is no simple data warehouse. I mean, we talk about star schemas, one fact table and multiple dimension tables. Those things are, possible. But in a real production environment, the schema is a lot more complex and it is also grows organically, right? So it is very complex. So this is what they got. And of course, as you can imagine, many queries involve multi-table joins. So this actually is just to give you a feel that, there are business users, they are doing a lot of OLTP transactions, and then the data comes through a complex ETL chain, and it lands into this UDM database that you see here, okay? So this is the final resting place for their analytics. And then here they're running reporting queries, including ad hoc queries by their analysts who are analyzing how customers are using, how their insured patients, this is health insurance, are using hospitals, what was the average stay in a given hospital for a given sickness, so on and so forth. So they can drive this kind of learning to control the cost and to provide much better services to their customers, right? So this is what they got. And they got, I mean, of course, queries are many varieties, but they picked two typical query patterns, which is, I would say a not so complex query and a more complex query. All the things that you see here, the arrows, these are the joins, okay? So these are the kind of queries they run, right? I just wanted to showcase to you, these are not your, one simple query. These are multi-join, multi-table kind of queries. So this is their environment. And they have been running this data warehouse for last 3-4 years. And interestingly, they were not running on SQL Server. They were running on Sybase. So the challenge that they faced was their data was, growing. So, 3 years ago, the data warehouse query performance was acceptable, but as data grows and things get more complex, it was not meeting the SLA that they wanted to provide to their analyst and everybody. And they were concerned, the data is growing even more. So question was, what should we do? So they were looking for a technology that could keep up with the demands of the workload for the next few years, right? They were not looking for, band-aid kind of a solution. Let me, optimize this query here or do something. They wanted to look at something, significant so that they feel comfortable that their business will be fine in years to come. So, so what happened was we worked with them, and this customer actually, Daman, they hired a consulting organization and asked them to help Daman with the right technology. So what this consulting company did, they did a POC across multiple vendors. They did a POC with SQL Server, Oracle, HANA, and many other competitive technologies to see which technology will be the most suitable technology for Damon's business requirements. Okay, and and I was fortunately involved in that POC, and I think this is one of our proud moments with this technology, the Columnstore technology, that we beat the competition for this workload hands down. And their solution, I mean, it is obvious they will use, column store index. So they used CCI, cluster column store index, on the fact table, and they combined it with a non-clustered index also. So important point is this would not have been possible in 2014, right? Because NCI was not available. And even the dimension tables, they created CCI because a lot of the dimension tables were very large, okay? And the beauty of all this thing is the POC was completed under 60 days, okay? And the next thing I want to show you, which is quite impressive, and this is actually a case study that we have done. So let me just walk you through this thing, okay? If you look at the first part, okay? First part, this was a complex query. Remember, there were two kinds of queries, simple query and more complex query. So what you see here, it is time taken is 2.8 minutes, 3.2 minutes, 5.6, and so on and so forth. So what I want to show you on the first column on the left box, with 2016, we finished that complex query under 3 minutes, okay? And also notice in 2014, SQL Server 2014 with Columnstore, it took around 26 minutes, okay? So imagine this, right? The 2016 Columnstore improvement has improved the query performance for these guys over 10x, right? That's huge. And also, I cannot really show you who were these competitors, but they were all, big ones like HANA and the Oracles and the Sybase. So you can see that SQL 16 delivered the best performance for this workload for this customer. Now, the typical user query, this was not so complex query. Here, x-axis is in seconds, 1.1 second, 25 seconds, and so on and so forth. Actually, that is 2.5. I'm wrong. So again, if you look at 16, it ran the query in, on average, 1.1 second. And notice on 2016, it was around 4.1 seconds. So for this typical user query also, it ran 4x faster. So that, I think, is a pretty, convincing argument for some of us that SQL Server Columnstore Index is industry leading for many customer workloads. And when I say industry leading, I'm not saying in a very light way. We in fact lead the TPCH benchmark across multiple terabytes of databases, like 10 terabyte, 30 terabyte, and so on. So it just convinced us that that SQL Server 2016 Columnstore is a pretty compelling solution for analytics. So at least I want to impress upon you all who are listening to this presentation to consider Columnstore for data warehouse using SQL 16. So that was the number that I showed you in the previous slide was in their benchmark testing. So then they deployed the solution in production. And what I want to show you is in production, they had many queries like ad hoc analytics, scheduled reports, and then monthly reports, right? And you can see across the board, everything got improved in a very significant way, 3x, 5x, and so on and so forth. So this customer is so pleased with the delivery of 16 Columnstore performance. So they said, let's step back. And for them, they were not actually a significant SQL Server shop, but they said, given SQL Server can deliver such a performance, they have decided they will look back and step back and take other applications and see how SQL Server can help. All right. So now what I want to show you a recording. Unfortunately, I will not be able to show you the audio, but I think it is a very interesting point. So I want to show you this, and this is available in YouTube. So I'm just going to guide you on this one. So what you see is when the daemon ran the queries, so they are looking at these tables, which are, remember the UDM was a database. They had these, tables. And if you look at the count, right, these counts are in billions, like a large number of rows that they have, right? And I'm just going to run this guy. And so they are running this. And I just want to show you a kind of query they ran and the time it took for them to run it. Okay, so it is, so they're going to run this query. Remember, this is not a simple query, right? This is a query. And then when they ran this query with Columnstore, it runs like in seconds. So he already running the query here. And what you will see is, and the query already finished in 2 seconds, right? So this is an example I wanted to give you that a traditional workload with Columnstore data warehouse, they were running a pretty massive amount of queries, and the query ran in this example under 2 seconds, right? That's the key value I wanted to show you. Any questions on this? If not, then I will move to the next customer.
There have not been any questions yet. So I'll let you know if we get any.
Jim?
Yes. Can you hear me? Hello? Can you hear me?
Yep. Any questions? Or let me just do one thing. I think my video is still running and getting complicated. Okay, thank you.
So far, no questions. If we get any, I'll let you know.
So Jim, I was wondering if there is any question for me.
Not yet, Sunil. Not yet.
Yes?
No.
Okay, all right. So the next solution that I wanted to talk about was a real estate property search. Now, the interesting part about this application was this is not a data warehouse application. And this is one example I wanted to give you where, application is not really, you will not think of Columnstore as a first solution, right? So what this company, First American, had was they list the properties. So there are 150 million plus properties in the United States of America, that many properties. And their customers, First American customers, what they are doing is, they are like, the customers are mortgage brokers and real estate agents and whatever not. And they are searching for properties satisfying certain criteria. So for example, you can say, show me a property or properties that are in this price range, they have this kind of bedroom, this is the square feetage, and so on and so forth, right? So they had approximately 150 columns of which are representing different kinds of properties, like different kinds of attributes of those properties, right? And customers will go and search and filter the rows on those properties. And the queries that they were running were, of course, will be selective, because you don't want to select a lot of properties meeting the criteria, right? You will say, give me top 10 or top 100. And so that's what the application was. And so this is not, as you can imagine, it's not an analytics kind of a query, right? So they were running that. And also, they had a ETL, which is approximately updating 1 million rows per day. Okay. Now you may wonder why 1 million rows per day update is happening to the properties. Think of this, right? Every year, the tax on the property changes. And if there are 150 million properties, at least there are 150 million changes per year, right? If you divide that by 365, you will get approximately, 400,000 changes per day. So you can imagine, right? It's like a large number of updates. And the reason I'm mentioning update is because updates are not efficient in Columnstore index. Update is a lot more expensive in Columnstore. So from a query perspective, it did not seem like it is an analytics kind of workload. And also from the ETL perspective, it seemed how will we handle this kind of a update in an efficient way. So this is what it was. So anyway, so this customer was using SQL Server 2014. I want to highlight that they were using 2014, but they did not think that Columnstore will be useful. So they did not even try it. So what they did was they said, okay, I'm going to use page compression, which has been our recommendation for data warehouse starting from 2008. So they were running page compression. And then what they did was, as you would do, that they said, what are the common queries I do in this table? So they said, okay, these are the 20, 30 common queries I do. So let me create appropriate indexes on those columns so those queries will run faster. So no doubt those queries were running fast, but the problem was as soon as customers wanted to query on predicates that were not indexed, the query performance was insanely slow, because what it would mean is it is going to scan the whole table, all right? So now one thought may come to mind is, hey, why not create one non-clustered index on each of those columns? So you will have 150 non-clustered indexes. It may be good for the queries, but it will be death for ETL, right? I mean, if you have 150 indexes, your ETL will be excruciatingly slow. So that was not a solution, okay? So that was a challenge. And their success criteria was that 95% of the queries should finish under 5 seconds, and they did not want to have any query taking more than 10 seconds. And the reason is, right, I'm searching for a property. I give some criteria. If the result does not come to me in a reasonable time, I will just skip the search, right? It's not a good user experience, and they wanted to support up to 400 concurrent users. And this is the example of some of the queries that were running very slow for them. It was like a select list from the table property, and they had some sort of a predicate. And notice here it is taking 8 minutes. Imagine this, right? If I'm searching for a property, it's taking 8 minutes. I'm gonna just not search for my property. Some other example here, I'm taking around 10 seconds. So these are the kind of queries. So what we did with them was we said, okay, we will use Columnstore index to see if it helps. and we narrowed down the total set of queries to, I think, around 200 queries, which will represent the workload. So this, what I'm showing you here is a traditional row store table, right? This is a row store table, and you have one or more B-tree indexes. They also created a full text index on it, which is, you can create on a row store, nobody stops you. And they also had a spatial index. Why spatial index? Because, you can, on a map, you can draw a line to say, I want to search for properties in this geographical region. And so they had a spatial index to figure out the region, okay? So what we did for them was we created a non-clustered column store index. And the reason we created a non-clustered column store index? Because they needed full text index, they needed spatial index, which was not supported on cluster column store index, right? So, and the storage was not an issue for them. The issue for them was the query performance, okay? So they created this non-cluster column store index. That's all they did, okay? And with that, what happened was their query performance improved in a very significant way. And I want to share those numbers with you in the next couple of slides. So this is pretty much the solution. You don't have to change anything, right? In fact, what they did was they dropped some of those indexes they had created for query performance, because now the non-cluster column store index can do very good query performance. So one question that you may ask is, because remember, in the column store, data is not ordered by any column. It's not ordered. So the question was, when people run the query on the column store index, would it not involve scanning the 150 million rows that is representing all the properties? And that would make the query very slow. And what we found was that we were scanning only very few row groups when we were running those queries. Row group, if you recall, is a unit of compression for column store. And the reason it happened that way, because for each column within a row group, SQL Server maintains the min and the max value of that column. So the way the predicates were given in the query, we were able to eliminate many row groups because of those predicates, and we had to scan only a very small subset of data to deliver the query performance. So that's what happened behind the scene. And again, I would say this, that I did not expect the query performance to be so good, but it turned out to be so good. Okay. Now here's the challenge. They did not want to upgrade to 2016 right away, because they have a procurement process that takes a year or so. So they were running on 2014, and this is the beauty of it. So they said, could we not do the same thing with 2014? Okay. So here's what we did for them. Clearly, CCI in 2014 or even today does not support spatial or full text indexes. All right. So what we did was, and notice this is actually, I'm saying, think outside the box. So what they did was they created a cluster column store index here, and they copied the same data on the row store table. Okay. So essentially they have two copies of the data. And what they did was they created the full text index and the spatial index on the row store. And then they wrote a layer on top of these two tables. Think of these two tables like a view. And that layer actually had the logic. Depending on the query that is sent to them by the client, which is a web-based client, they will send the query either to the cluster column store index or to the right side. So that's what they did. And by doing this, I think this is what I'm talking about. Like, this is how they directed, and this is how the query looks like for them, where they are searching in a property which is going to the row store, and they are doing qualifying properties using the column store index. Okay, this is what they're doing. So this is pretty much what they implemented, and once they migrated to 2016, they may switch back to NCCI. So this is the solution, and the numbers are phenomenal. Okay, so the data compression with column store index was around 13x. They went from 550 gigabyte of page compressed data, and they use CCI, it became 13x, right? Pretty mind-boggling. And their CPU consumption went down from 23% to 7%. Now, why this is important? like this property search. Yes,
We
is a
actually
question?
we got some questions queued up, so I don't know if you want to take
Let
them
me
now or if you
do.
want to just let's finish this next part.
Let me finish this section and
Okay,
then I'll take the question.
sure.
Right. So the CPU consumption went down from 23%. This is the average, and this is important too for some American because there is a peak season for buying houses. For example, during the summer, people buy houses, so their load is much higher. So they were happy that if the CPU consumption is low, they can deliver the workload performance to their customers with fewer number of boxes, right? So they're pretty happy. And the most important thing is the query performance that you see in the bottom here. The query performance was on average with RowStore was 2 minutes and it went to 2 seconds. So it's like, imagine this, right? It has speed up the query performance by 60 times. So that's the solution that is in production today. And again, the point I was trying to make to you is that it does not necessarily mean it has to be analytics scenario. You can use Columnstore for many other things. Okay, Jim, I'm ready for the questions.
Okay, so apparently some people were watching the data amp, and there's some 2017 questions. Ned asks, will Columnstore be enhanced in SQL 2017?
Yes, so the Columnstore index will support lob data type, which was not available in 2016. So it has been enhanced. And I think the more important thing that has been done in 2017, which they must have talked about, is the adaptive query processing, adaptive query optimizer. So what happens is, when, optimizer is heuristic based, and, sometimes it gets it wrong, right? If the size computation of intermediate results is way off, it may choose the wrong strategy. Now with the adaptive query processing, what happens is once the query runs slow, it has the real runtime statistics available for those queries. It feeds that information next time when you run the query. So that will benefit not only traditional queries, it will also help the columns of queries.
Sounds good. Ned then asked a follow-up. There are big differences for clustered column store indexes for on-disk versus in-memory tables. Will clustered column store for in-memory get closer to on-disk functionality in SQL 2017?
That's a great question, and I don't know how many people understand the question to that level. And but let me say this to you: the cluster column store index, which is supported on disk, it has two components: the delta store and the compress store. Both are on disk tables. And what customers have been asking us to support a in-memory version of that column store where the delta store is in memory and the column store also is in memory. And that is not at least on the roadmap for 2017. I mean, of course, 2017 was announced today, but that is something people have been asking us to do. So, but answer is no at this time.
Okay. Ashish asked, can SQL Server 2016 have large table in memory limitations size-wise?
So, Ashish, is your question related to in-memory OLTP or column store? If it is for,
He left.
oh, he left. Okay.
Yeah, he asked
All
about
right.
a minute ago and then he left.
Okay, that's all right.
So,
But let me answer the question. The cluster column store index is using on disk storage format.
oh, he's
There
back.
is no, so Ashish, the point is that the cluster column store index using on disk format, there is no requirement that the full column store index has to be in memory. We only bring the data as needed to the memory. Now, if you're thinking of cluster column store index in the context of in-memory OLTP, the column store compression is around 10x. So if you have space for keeping the in-memory table in memory, we are gonna just ask you for additional 10x memory, 10% memory, not 10x, 10% memory. So that's pretty much the guideline.
Okay. He's actually back. He said he commented column store. So I think you answered.
Okay. All right. So let me do this, Jim. I think if you don't mind, let me go to other two scenarios. I have literally
Sure.
20 minutes,
Yep.
and those scenarios will take me hopefully 7 or 8 minutes each, and then I can take more questions. Is that okay?
Yeah, that sounds fine. I'll save them
All right.
for you.
All right. Thank you. So the next scenario I want to talk about is the non-clustered column store index, right? We call it as a HTAP scenario. HTAP stands for hybrid transactional analytics processing. That means I'm running both my OLTP and analytics workload on the same table, right? That's important. So I'm not a financial expert, okay? I struggled understanding the business problem this FIS company had, but conceptually this is what it is. They actually have an application which is used by stock traders and brokers for getting short-term loan on security. So for example, if I'm processing a trade and my customer buys 10,000 shares of some company, I may not have it. I can just borrow it and give it to them and then get the price. I don't understand this thing too well, but the key point was they have these kind of transactions that are going on. So while they are going on, imagine if you are a trader and you want to say how much risk this has, you want to do some trend analysis. Okay, how's this stock trending in the last 5 minutes, right? Or last 10 minutes? How's it trending? Because maybe it is hot because some major announcement has come and so on and so forth. So you can imagine these trend analysis is actually the difference between profit and loss. So critical for this business and any financial business. Okay. So what they had done, they were using 2012, SQL Server 2012, and they were using row store for transactional processing, which is fine, right? Transactional amount, this is good. Now to do the trend analysis, what they were doing was they were doing a ETL every 5 minutes because ideally they wanted to do real time, but that capability was not available in 2012. So they were doing ETL every 5 minutes. And so that means their traders, they were getting the trend analysis for that was 5 minutes older. Now, some of you who have been involved with the financial industry know the intricacies of that. 5 minutes may be too late. They want to be able to analyze the data as it is happening now, right? Okay, so that was one angle. And second problem was that it's not a problem, but it's an important data point that the total transaction volume for the given day for this customer was 1.2 million rows. Not a whole lot of rows, right? 1.2 million, because we are thinking billions, but this is 1.2 million. Now, why this is important to mention, the column store index compresses data after it accumulates 1 million rows. Agree? So the thing was, if the number of rows in the table is 1.2 million, you will not think of column store as a solution, right? Because people think column store means billions of rows, right? That kind of deal. Okay, so and what they did was they have a pretty rich UI, a dashboard, which their traders look at and look at the trends and everything else, right? So they had this requirement that when the trader goes to the dashboard should get filled, right? It has multiple frames. I mean, if you look at the UI perspective, the dashboard has multiple frames, and each of the frame was running a query on the SQL Server to get the information to populate that, right? So that was a requirement. So clearly, what they wanted was when they heard about non-cluster column store index, they said, let's use non-cluster column store index to get real-time analytics, right? So that's, we said, yeah, that makes sense. And their main concern there was, what is the impact on my transactional workload if I create a non-cluster column store index on my table? That was one concern. And also thing they wanted to do was, they wanted to simplify their operational work because they didn't want to do ETL every 5 minutes, because you can imagine, right? Not only it's not delivering the right value to their customers, it is also very complex to manage ETL every 5 minutes. So when we started discussing this one, so the question, as I told you, was 1.2 million rows doesn't seem like a column store kind of a solution, and column compression would only happen after 1 million rows. If they're loading 1.2 million rows in the 8 hours of business, the query performance benefit they will only get after 6 hours into the data load, right, into the work, and that doesn't help them. So what should we do? So that was a challenge. So and again, this is again thinking outside the box. So what we did was we considered two configurations for them. One was use your existing schema and just create a non-cluster column store index. And the second option we considered was move your data, transactional data, into in-memory OLTP tables and use a column store index on top of that. So those are the two configurations that we considered, all right? So we first said, assume data is fully compressed. Let's want to make sure that does NCCI gives you the right analytics query performance if everything was compressed, because that's the best case solution. So we basically compressed, loaded 1.2 million rows in the sample database and created an NCCI on top of it, and they ran their dashboard queries, and it was phenomenal. They were just happy that everything is running perfect. They said, this is the performance, if you can provide, they'll be happy, right? But the challenge was, you don't get 1.2 million compressed rows in the beginning, right? Because you're getting data. It's a trickle down. They start every day with the 0 rows, and then 8 hours they get 1.2 million rows. So it's like 150,000 rows per hour. So 6 or 7 hours later, data will get compressed. That was a challenge. Okay. So what we did. So this is something very interesting. So the way we delivered the solution with NCCI, and we used the force compression. This option actually was available in 2014, but it was under the covers. But now it is a fully supported option using reorganize. What you can do is you can run a reorganize on a table with column store index, and you can say compress the data that is sitting in my delta store. Okay. So the delta store, you don't have to wait for a million rows, you can force compression. So what we did was they run this reorg command every hour to force compression. Is in fact, it is saying around 100,000 rows. So they just run it, you can imagine, right, 12 times in a day, because 1.2 million rows, they're running that command. So every 100,000 rows, you're getting a compressed row. Okay, that's what they did. And they found that even by doing that, the query performance for analytics was not the best, which is when everything is compressed completely, but still it was pretty good for their SLA perspective. And also, as I said, we did the experimentation on in-memory OLTP as well. The numbers were very comparable, but they felt a bit more comfortable using the disk-based tables because that's what they have been using since SQL 12. So they decided not to go with in-memory OLTP, and they were just using a non-cluster column store index. And I just want to share with you the numbers. So in the table on the side, you see that the column here, these are the dashboard queries, right? So number on the NCCI for the dashboard query, like in row store, it is taking 180 milliseconds. On NCCI, it's taking 10 milliseconds. So you can see across the board, the query performance was actually quite good, right? And this is, they're testing with the 100,000 force compression every 100,000 rows. And they also measured the performance of the dashboard. Like I click the dashboard, how long does it take for me to populate that? And you can see that their dashboard was getting populated under 3 seconds, and that was their SLA. So they were actually happy that NCCI is able to deliver the dashboard in real time. This is the important point. They wanted to provide real-time analytics to their traders, right? And they actually were so happy, and they decided this is the solution they will go with. And they actually, they are not in production yet, but they will go in production very, very soon. So this is, actually, I'm sorry, they went live in production. This is, I didn't realize that. They went in production a couple of months ago. So again, I think the learning that I wanted to point out to you is that in the first blush, it did not seem like a solution for column store, but we made it happen, right? So that's the important point. And in this slide, I think the deck should be available to you. If you don't, send me the mail. I will send you the link. This is a case study that is already available in our Microsoft website. And this is a quote from their vice president, Aaron. And what he says is, with non-cluster column store index, we did not have to involve our DBA. Now, I will not say that, DBA should be involved when you create and drop indexes. I mean, but, Aaron being a vice president, he was a very hands-on technical guy. So I would say he was like a, semi DBA himself. So anyway, they did not involve anybody. They created the index, and their queries ran 4 times, 10 times, and 20 times faster. So this is the power of the non-cluster column store index that I wanted to showcase to you guys. Okay. Now I want to go for one more scenario, and hopefully I'll finish that in less than 10 minutes, and we can take some questions. Okay. The next scenario is also pretty interesting. It's a M-Files. It's a document management company. Think of it as like SharePoint, but a little bit different. What they have is, when you upload a document to a SharePoint, it sits in a specific directory. Now, the problem is, how do you find documents that are related through some properties, right? In SharePoint, it gets complicated. So what they decided to design this M-Files application, this is actually a very successful application. They have many, many customers running on it. So they organize the information about documents based on what is the organizational property rather than where it is stored, right? So you can, using some meta information about the documents, they can, organize data, give you almost like a dictionary kind of a view, like a directory kind of a view, and then you're fine. Like you can see here, right? It can show you the proposals in 2016, the projects and everything else, right? And it doesn't matter where document was stored. So they will give you this kind of a view. So this is their application. Okay. So when you upload the document, so the interesting thing is, each document that you upload, document goes to not in SQL Server, document sitting outside of SQL Server, but the properties of the document are stored in SQL Server table. So each document upload is inserting approximately 60 inserts into their meta tables managed inside SQL Server. All right, this is what they do. Now, if you change the meta information in a document, for example, you can say, this document is for this conference or something else, it can also make large number of changes in other documents because there is a references and so on and so forth. So this is the OLTP part, because they are uploading documents which you don't think like a OLTP workload, but the meta information that is kept is like a transactional workload. Lots of updates, lots of inserts, okay? And then, they can provide these kind of views on looking at these documents, okay? These are the views. Now, these views, they create using some sort of a OLAP queries, which is like an analytics kind of queries, like group by, show me by this property, and so on and so forth. So those are complex OLAP queries, okay? This is what they had. So the requirement was that the metadata insert and update, remember they were doing 60 inserts per document upload, it should finish under 1 second. That's the requirement. And mass update to documents, if they are updating, like change a document in like a multiple documents certain way, they wanted to that update to finish in under 3 seconds. And the view listings must be produced in real time. When you show the listings, I upload the document, I do the listing, it should show up, right? It should not be the case, I uploaded the document, but listing doesn't show it, right? This is the real-time part of it. So their limitation, this is before they adopted Columnstore, the limitation was that once the repository of the document exceeded 10 million documents, they were not able to meet their SLA. They were not. And they were in fact asking their customers to break the repository into multiple repositories, and it gets very complicated. So that was a challenge they had. Okay, I'm going to rush a little bit here. So they were going to move away from SQL Server. They said, let us find some other solution because it is not working for our workload. They looked at Hadoop, HP Vertica, NoSQL solutions, and they rejected those solutions for many reasons. One of the reasons is that a lot of these technologies do not support ACID. They wanted full ACID transactional guarantees for their workload, which SQL Server provides. Of course, Oracle provides, and so on and so forth. They wanted to look for ACID. And the second thing was their solution was available both for on-premise as well as in the cloud. And this is something they liked about SQL Server, that it is available on premise, also as SQL DB in the cloud. So that was their reason to stick with SQL Server 16. So SQL Server. So when we talked about NCCI to them, like non-cluster column store index, they got pretty excited. They said, we'll definitely try this option in our workload. So that's what they tried. Now, the reason a lot of customers get excited about NCCI is because, just creating an index, you create an index and see what happens. If you don't like it, just drop it, right? It's a no change kind of a scenario, right? So they created that. And essentially what they did, you see the bottom here, these are the tables they had, and they created a non-cluster column store index. That's all they did. And the results are pretty phenomenal. So they said, remember their initial solution was up to 10 million documents. They had a test environment with around 77 million rows, 5 terabytes total database, right? And what they found was when they created that NCCI, the total impact on their OLTP workload, which is, when you upload the document 60 inserts, was less than 5%, which is pretty reasonable. They were pretty happy about it. But the query performance, notice the query is going from 6.5 seconds to 0.5 seconds or 2.6 seconds to 0.05. These are the OLAP kind of queries where you're grouping the documents, right? So they were pretty happy that now I can support a customer with 77 million documents, right? That kind of a deal. Right? It's a pretty huge. And those queries, that OLAP queries I'm talking about, they are not simple queries. They are pretty complex queries. This is an example of a OLAP query, right? This is what that is running on NCCI. So that's what they have deployed. And I just want to share with you their founder CTO statement that NCCI is just help them in a big way without changing their application. And I'm happy to say they are live in production. They are one of our reference customers. So anyway, so this is pretty much end of my presentation to showcase many, many scenarios for Columnstore. And Jim, I know we have 4 or 5 minutes. I'll be happy to take more questions.
Sure. Okay. So Ashish asked, should you still use SSAS when you have column store technologies?
That's right. So this is a great question. So analysis services is a very traditional solution used by, for multiple years by customers. And the rationale is this. Rationale is this. In analysis services, you can create pre-aggregated data through, multi-dimensional cubes, or you can even use the, tabular model to cache the data. And you can create, you can cache aggregated data and so on and so forth, right? Now the challenge with this aggregated data is, number one, it takes time to aggregate the data. And second thing is, when you aggregate the data, the fidelity of the data is much coarser, right? If you want to drill down, suppose I aggregate data, say on a daily basis, if I want to look at what happened in the last 1 hour, I will not be able to see that, right? Now this was fine before Columnstore came along, because if you did not have a Columnstore, the query performance will be very, very slow. Now with the Columnstore, there is an option where you say, instead of doing the aggregate, let me run the query directly. I'm not saying every customer will do that, but many customers have moved away from analysis services and do a direct query to Columnstore.
Okay.
Yeah.
Okay, this one's kind of a long one, and it's from Ned again. If you add a clustered column store index to an in-memory OLTP table, you cannot add or drop indexes or columns, use archival compression. But those restrictions don't exist for on-disk tables. Are there plans to change this for in-memory OLTP tables?
Right. So Ned, as actually Ned and I have exchanged many, many emails before. So Ned, I'm happy that you're on the call. Ned, as you know, that in-memory technology has some limitations, and our goal is to make it in parity with disk-based tables. Unfortunately, it is not the case today, but rest assured that we will get there. I don't have the time frame in mind.
Okay, I think we got time for one more. Why was Azure Cloud not used in the Daman Healthcare proof of concept?
Right. There are two questions here, right? One is the security angle, right? Many of the healthcare companies because of their lack of comfortness with putting data in the cloud prevents them. The mindset is not there, right? Because our cloud is HIPAA client and compliant, and so I don't know what would be the reason for them from a security perspective or compliance perspective not moving to the cloud. So that was one. So they just had a mindset of not moving to the cloud. Number two is their database is much larger. As you know, SQL DB at least supports 1 terabyte or less. So that was one concern from the size perspective, because if the database grows, what happens to me? SQL DW, which is our other solution to the like appliance in the cloud, which is scale up and down based on the requirement. That would have been a possible solution, but that solution was not available at that time to them, so they did not use it. And so those are the two reasons. I hope I convinced you, or at least that's the reason customers told us.
Okay. Well, I think that's all the time we have for today. Sunil, thank you very much for your presentation. It was very insightful. Everybody else, thank you guys for attending. This session, along with all other previous sessions, will be up on the IMVC YouTube channel. Please give it a check. Please check it out. And you guys all have a great day. Thank you very much.
Thank you guys. Take care. Bye.